Hey everyone, today we're diving into something we feel every single day, right? Temperature. We're going to go on a little journey from just the feeling of hot or cold to the actual science behind measuring it. So let's kick things off with a simple question. When you reach out and touch something, can you really trust your own hands to tell you if it's hot or cold? I mean, we use our sense of touch all the time, but is it as reliable as we think it is? Let's find out. Okay, so first up, we're going to put our senses on trial, basically. We're going to see if that feeling of hot and cold can actually be, well, totally wrong. All right, let's do a quick thought experiment. You can even try this at home later. Picture 3 bowls of water in front of you. Okay, the one on the right, bowl A, is full of nice, warm water. The one on the left, bowl C, is ice cold. And the one in the middle, bowl B, is just regular old room temperature water. Now imagine putting your right hand in the warm water and your left hand into the icy one. Hold them there for, say, a minute. Got it? Now what happens when you take both hands out at the same time and plunge them into that middle bowl with the room temperature water? What do you think you're going to feel? And here is the crazy part. Your right hand, the one that was in the warm water, is going to tell you the middle bowl is cool. But your left hand, the one from the ice water, is going to scream that the exact same water is warm. It's the same water. This just goes to show you our sense of touch is totally relative. It's not giving you a hard fact. It's just comparing what it feels now to what it felt a second ago. So, if our own hands can lie to us, how in the world do we get a real answer? Well, that's where science comes to the rescue. It gives us a reliable, objective way to measure this stuff. And that solution is what we call temperature. It's not about how you feel, it's a real, objective measurement. It's a number that gives us a solid, trustworthy way to know how hot or cold something actually is. Simple as that. And, of course, to get that reliable number, you need the right tool for the job. And that's where the thermometer comes in. It's the device built specifically to give us a precise reading and get rid of all the guesswork. Okay, so let's start with the one we're probably all familiar with. The one you reach for when you're feeling sick. The doctor's thermometer, or a clinical thermometer. The key thing to know about these is that they're specialists. They're designed for one job and one job only, measuring human body temperature. That's why the range is so narrow, right? Usually just 35 to 42 degrees Celsius, because our bodies don't really go outside that range. And thankfully, the ones we use today are pretty much all digital, which is way, way safer than those old mercury ones. Phew. And here's that magic number we all know, 37 degrees Celsius. But, it's really important to remember that's just an average for a healthy adult. You could be perfectly fine and be a little higher or a little lower. It can even change depending on your age or even what time of day it is. Now, using one of these is super simple, but you gotta do it right. You wash the tip, pop it under your tongue, wait for that little beeper flash, and boom, you've got your reading. It's so easy and definitely a lot more reliable than the old hand on the forehead test, right? All right, that's great for checking if you have a fever. But what if you want to measure, boiling water or some freezing chemical in a lab? Well, for that, you need a totally different kind of tool. So let's check out the scientist's thermometer. And wow, this really shows you the difference side by side. Just look at the range. A lab thermometer goes from below freezing all the way up to above boiling. We're talking -10 to 110 Celsius. But here's the most critical difference. Pay attention to this. You have to read it while it's still in the liquid. You can't take it out first because the reading will change in a split second. Yeah, so using a lab thermometer definitely takes a bit more skill. You've got to hold it straight up and down, not tilted. The little bulb at the bottom needs to be completely covered by whatever you're measuring, but, and this is important, it can't be touching the bottom or the sides of the beaker. And like we just said, you read it right there, on the spot. In a lab, precision is everything. Okay, so we get the tools now. Let's zoom way out and look at the bigger picture. We're going from something as everyday as the weather forecast to the absolute coldest it can possibly get anywhere in the universe. I love this quote from the amazing Indian scientist Anamani. She said, "Wrong measurements are worse than no measurements at all." And that just perfectly sums up why this is all so important, right? A bad number isn't just useless, it's actually dangerous. It can lead you completely astray. Anna Mani's work was a total game changer. They called her the weather woman of India because she designed and built all these incredible instruments for measuring weather. And her obsession with getting it right, with precision, helped India get really good at forecasting its own weather, which had huge impacts on things like renewable energy. All of that came from understanding just how powerful one accurate measurement can be. So, you might have noticed I've been saying Celsius this whole time. That's the scale most of the world uses for, well, pretty much everything. But if you're in the US, you're probably thinking in Fahrenheit, and that's totally fine. That normal body temp of 37 Celsius, that's just 98.6 Fahrenheit. They're just two different languages for talking about the exact same thing. So, we know things can get incredibly hot, right? I mean, the core of the sun is millions of degrees. There's really no upper limit. But what about the other way? What about cold? Is there a bottom? Is there a point where things just stop getting colder? Turns out, yes, there is a limit. It's called absolute zero. It's minus 273.15 degrees Celsius. And this isn't just, really, really cold. This is a fundamental law of the universe. It's the theoretical point where all motion stops. Every little jiggle and vibration of every atom just ceases. It's the ultimate final cold.
And that kind of brings us full circle, doesn't it? We started this whole thing by proving how easily our sense of touch can be tricked. So it really makes you wonder, if our most basic physical sense is this unreliable, what else are our senses getting wrong about the world around us every single day? Just something to think about. Thanks for joining me.